Hi all, in this video we learn Introduction to Trigonometry chapter part 1. So the subtopics are Introduction, Angle, Positive and Negative Angles, Measurement of an Angle, Trigonometric Ratios. So these are the 5 subtopics we are going to learn. So in that first one, Introduction to Trigonometry. So in this introduction, what is trigonometry? The word derived from where? So these all things we are going to learn. So the word trigonometry is derived from two Greek words. In that, one is trigonon, and other one is metron. So from these two Greek words, this word trigonometry derived. And what is the meaning of these two words? Let us understand. Here again this trigonon, there are two words. One is like tri and other one is ganon. So tri mean 3. Ganon means sides. So 3-sided figure or 3-sided polygon. So a polygon with 3 sides is called as triangle. We know that already. So 3-sided polygon is a triangle. And other word metron means measurement. So finally trigonometry means what we say? Measurement of triangle. The meaning is measuring the triangle. Okay, measuring the triangle mean, so measuring either angles or sides. So angles, sides, or many more things we can measure, like area we can measure, or length of the median we can measure, or angular bisector we can measure, right? So many things. But in class 10 we learn only the relation between angles and sides only. So let us discuss only angles and sides in this chapter. Okay, so now next topic, that is angle. What is angle? So angle is basically what we say, the amount of rotation from initial ray to, between two rays I am taking, like hands of the clock. Suppose OA is initial ray. This is initial ray. And the same ray it is rotated till here, suppose. Like our hand or minute hand, it is rotated till OA dash. Okay, so this is like final ray we can call. OA dash is a final ray. So as I told, the amount of rotation from initial ray to final ray is called angle. So here initial ray is OA and final ray is OA dash. So the amount of rotation from initial ray to final ray is this one, this much. Okay, so this is angle. So we denote that with either theta or alpha, beta, gamma and so on. So or angle AOA dash also you can write it. Not A dash O A. It is starting from AOA. So it is starting from AO. So you have to mention it as like angle AOA dash or with the letters theta you can say. But not angle O or not A dash O A also. It is starting from AOA dash. So we need to start from AOA dash only. It is not, in lower classes you may learn like angle mean A dash O A or AO A dash or angle O. But here you cannot say like that. Okay, starting point to ending point only you need to measure the angle. So this is angle. That means amount of rotation from initial ray to final ray. We call it as like angle. So we move to next concept, that is positive and negative angle. When we say the angle is positive, and when we say the angle is negative. So in case of positive angle, the amount of rotation from initial ray to final ray. Suppose observe the diagram. This is OA, initial ray I am taking. This is initial ray and final ray is OB. This is OB, final ray. So the amount of rotation from initial ray to final ray is this one. So now the direction, if you observe carefully, initial ray to final ray is this one. In this direction it is moving. So that is anti-clockwise direction. Not clockwise, opposite to the clockwise direction. So that is anti-clockwise direction. Then we call it as like a positive angle. Angle is positive if the amount of rotation from initial ray to final ray is in anti-clockwise direction. So that is a positive angle. In the same way, suppose the amount of rotation from initial ray to final ray is in the clockwise direction. This is a clockwise direction from initial ray to final ray. Then we call it as like a negative angle. So this angle is a negative. Hope you got this too. Like what is introduction part and angle, positive angle, negative angle. Then we move to measurement of an angle. Next concept. So how to measure the angle? Measurement of an angle. Measurement of an angle. To measure the angle, there are three methods. So first one is degree measure. First one is a degree or English system of measurement. English system of measurement, or one more name is there, that is sexagesimal system. Second one is French system of measurement, or grade system, or centesimal also we call it. And third one, radian or circular measure. Radian or circular measure. So now let us discuss in detail about these three measurements. Then only we'll understand like how to convert like degree to radian and radian to degree. These things you are having for your board examination. Okay, so but I am going to explain in detail. Very basic questions you are having, but let us discuss in detail about all these things. So first one is a degree measure. To measure any physical quantity, definitely there will be some unit. There will be some unit. So to measure the degree also, that means angle also. To measure the angle also, in degree measure, we have one unit, that is a degree. In degree measure, it is a degree. Okay. And what is 1 degree? What is 1 degree? So let us start in detail about this degree measure, that is like from degree onwards. 1 degree is what? So 1 degree usually we write like this. This is 1 degree. So 1 degree is exactly what? 1 out of 360th part of 1 out of 360th part of complete rotation. 1 out of 360th part of complete rotation only, we call it as like 1 degree. Suppose complete rotation mean it is like circular form. The angle in this is 360 degrees. So if this angle is divided into 360 equal parts like this, divided into 360 equal parts. So the angle in each sector, we call it as like 1 degree. Like this, we are dividing this into 360 parts. So the central angle in each sector, this angle, you can take it as like 1 degree. This is 1 degree. Okay. So further, this degree, this smaller part, like 1 degree out of 360, out of like 1 out of this 360 parts, like we call it as like 1 degree, no? That 1 degree again divided into minutes. So here 1 minute is what? 1 minute we denote like this. This is 1 minute. So 1 minute is what? 1 minute is 1 out of 60. That means 1 by 60th part of 1 degree. We can say as like 1 minute. That means you are dividing 1 degree into 60 small parts. So each part will give us like 1 minute. So this is the notation for minute. So 1 degree is equals to 60 minutes. So 1 minute is equals to 1 by 60 degrees. 1 by 60 degrees. In the same way, further we are dividing minute into 60 parts. So each part will give us like 1 second. So again 1 second. That means 1 minute we are dividing into 60 equal parts. So 1 out of 60th part of 1 by 60th part of 1 minute is called as 1 second. So 1 second we can write it as like this. And here few note points we need to remember. 1 minute we can write it as like 60 seconds, and 1 second is equals to 1 out of 1 second is equals to 1 out of 60 minutes. Okay. So hope you understood this concept. Like degree measure, all the subunits also I taken, like degree is what, minute is what, and second is what. Right. So in the same way, we start with grade measure. In this grade measure, you need to measure an angle. Unit is grades only. Unit is grade only. And what is 1 grade? 1 grade, we write it as 1 G. This is 1 grade. 1 grade is exactly what we say, like in previous thing what we taken, 1 degree is like 1 by 360th part. But in this 1 out of 400th, 1 by 400th part of complete rotation. 1 upon 400th part of the complete rotation only. Complete rotation means angle is like here in this 400 grades we can say. So in complete rotation, the angle in grade system is 400 grades. Right. So if we are dividing this angle into 400 parts, in previous case only 360. But in this case, we are dividing into 400 small parts like this. Okay. So each part, the central angle of each sector is equals to, this angle is equals to what? 1 grade. 1 grade. In the same way, minutes. 1 minute is what in this case? So there we taken 1 minute is like 1 by 60th part. But in this case, 1 by 100th part of 1 by 100th part of 1 by 100th part of 1 grade. 1 grade is 1 minute. That means 1 grade is equal as to 100 minutes, and 1 minute we can say 1 upon 100 grades. 1 upon 100 grades. So again this minute in grade system we can divide as seconds. So 1 second, the notation for second is same as like degree measure, only 1 second is like this we can write it. So here again 1 by 100th part of 1 by 100th part of 1 by 100th part of 1 minute. So that means 1 minute we can write it as like 100 seconds. So 1 second is equal as to 1 by 100 minutes. Hope you understood this grade system also. So then we move to third measurement of an angle, that is radian or circular measure. Radian or circular measure. So in this measurement, the angle like unit is what we can say radian only. Unit is radian. So 1 radian we can write 1 to the power of c. That means circular measure, no? So 1 cu 1 radian we can say. We can write it like this 1 c. Okay, that is 1 radian. And what is 1 radian? 1 radian is what exactly? So concentrate here. This is very good concept. 1 radian. In any circle, suppose I am taking a circle of radius r. A circle of radius r. Arc length also. Suppose the arc length here what I am taking same r only. This length also, arc length also r units only I am taking. That means AB length is equal as to r. And by joining this OA we get one sector that is AOB sector. In this the central angle is exactly 1 radian. So here we need to remember one thing, radius of the circle is equal as to length of the arc. So length of arc is equal as to radius of the circle. At that time 1 radian is equal as to like central angle only. Central angle only we can say. This is 1 radian. So these are the 3 measurements of an angle. And now one more important point related to this concept, that is relation between all these 3 measurements. So under one note point I am giving this. So that is d by 90 is equal as to g by 100 is equal as to c upon pi by 2. C upon pi by 2. This is the relation among all these 3 measurements. So if you remember this one formula, you can convert degree measure to grade, grade measure to circular, degree to circular, all among we can convert easily. So for that 2 examples I will take. First example is converting degree measure to circular. Convert 60 degrees to circular measure. So just if you remember this one formula, you can convert it very easily. So what is given? Degree measure is given. That means D value is given as 60. And formula you know already, that is D by 90 degree to circular measure, C upon pi by 2. So D value replace it with 60. So 60 by 90 is equal as to C upon pi by 2. So 0 get cancelled. 3 2 times, 3 3 times. That implies 2 by 3 into pi by 2 is equal as to C. So 2 and 2 get cancelled. So C is equals to pi by 3. That means 60 degrees is equals to pi by 3 radians. Pi by 3 radians. This is one method. And in another simple way, like shortcut method we can say, so pi is equals to 180 degrees. This one simple thing, if you remember, pi is equals to 180 degrees. And from this 1 degree is equals to, we can write it as like pi upon 180. Pi upon 180. So 60 degrees is equals to, we can write 60 into 1 degree. That means like 60 into pi by 180. So that is pi by 3. This is another way to remember degree to circular measure. Okay. So next one more example. Second one, circular to degree measure. How to take? One more, convert 2 pi by 3 to degree measure. To degree measure. So again, same formula we can use. And here given C value. C is equals to 2 pi by 3. That means circular measure is given. So C is equals to 2 pi by 3. And same formula we can use, that is D by 90 is equals to C upon pi by 2. So that gives D value is, we need to find it. So D by 90 is equals to C value is 2 pi by 3 upon pi by 2. Pi by 2. So pi and pi get cancelled here. That is D is equals to 90 into 4 by 3. So D is equals to 120 degrees. And in more easier way you want to calculate this. This is the like method you have to remember. And another one is like pi is equals to, we know already 180 degrees. Pi is equals to 180 degrees. So 2 pi by 3 is equals to 2 into 180 degrees by 3. So that is 120 degrees. 120 degrees. So like this we can convert from one system to other system. Hope you understood this. Next, moving to next concept, that is trigonometric ratios. Very important concept. So next one is trigonometric ratios. For this, first one, ratio, like unit is what? No unit. Trigonometric ratios. These are ratios. Like you are taking 4 centimeter to 5 centimeter. The ratio is 4 is to 5 only, not 4 centimeter by like something. Okay. So here actually it is 4 centimeter by 5 centimeter, mean centimeter will get cancelled. So there is no unit for this. No unit. Okay. And in a right angle triangle, suppose I am taking ABC be a right angle triangle. In this right angle triangle, ABC right angled at B, and remaining two angles, what are those? A and C, we can call it as like angle of measurement. Suppose C I am taking as angle of measurement in this. For this C, AB side is like opposite side. AB is like opposite to the theta. And in this AC and BC, AC is the hypotenuse. Hypotenuse we can say. And BC is adjacent to the theta. So when you take theta, like C is the angle of measurement, this you remember like opposite to this theta and adjacent to this theta, and another one is like hypotenuse, we know that, right? So if we are taking ratio of the sides here, observe carefully, there are possible ratios AB upon AC. This is one ratio. Then BC upon AC. This is another ratio. Then AB upon BC. AB upon BC. This is one ratio. Then AC by AB. AC by BC and BC upon AB. So these are the possible ratios. No other possible ratios in this. Okay, only 6 are there. These 6 only we call it as like a trigonometric ratios. So first one is sin theta, and this one we call it as like cos theta. This is a tan theta, tangent theta, and this one is cosecant theta. This is a secant theta, and next one is a cotangent, that is a cot theta. So here observe carefully, AB is like what? Opposite side to theta upon hypotenuse. AC is hypotenuse. And here this is adjacent side to the theta upon hypotenuse. And this one is opposite side upon adjacent side. Opposite upon adjacent. And next one is AC is like hypotenuse. Hypotenuse upon opposite side. And this one is like hypotenuse upon adjacent side. And this one is like BC upon AB, that is adjacent upon opposite. Adjacent upon opposite. Here in this, if you observe carefully, there is some relation between sine and cosecant, cos and secant, tan and cot. So if you observe, these are reciprocals to each other. So those only we can call it as like reciprocal relations. Reciprocal relations. So in that reciprocal relations, like one is reciprocal to other, like sine and cosecant you take. So first one is cosecant theta into sine theta is equals to 1. Both are cosecant and sine are reciprocals to each other. So cosecant theta is equals to 1 by sine theta you can write, and sine theta is equals to 1 by cosecant theta also. And second one, secant theta into cos theta is equals to 1. This is another relation. And third one, cot theta into tan theta is also equals to 1 only. So these we call like reciprocal relations. And some more relations are there. By dividing two ratios, we will get third one. So if you observe carefully, by dividing sine and cos, we will get tan theta. So sine theta value, first one is like tan theta is equals to sine theta by cos theta. Sine theta by cos theta. To prove this, what I take? Sine theta upon cos theta values I will take in the same triangle. Sine theta by cos theta is equals to, sine is AB upon AC divided by BC upon AC. So denominator AC will get cancelled. So AB by BC. AB by BC value is tan theta only. So like that, tan theta is equals to sine by cos. In the same way, cot theta is reciprocal of this. Cot theta is equals to cos theta upon sine theta. Sine theta. So these are the trigonometric ratios, and along with that reciprocal relations and quotient relations. So everything you have to remember. Okay. Next, 1-2 problems related to this trigonometric ratios we discuss. By solving those 2 problems, you can solve any question related to trigonometric ratios. So in that first example, example 1, in triangle ABC, That is like in given triangle ABC, find all t ratios, that means trigonometric ratios of angle C. All trigonometric ratios of angle C. This is one type of question. If you remember exactly two types of questions in this, so any sum you can do easily. Okay, this is A, B, C. So all trigonometric, this is like AB is 4 centimeter, BC is 3 centimeter, right? So only two sides are given here. So third side we need to find by using Pythagoras theorem, right? So in this triangle, AC square is equals to AB square plus BC square. So AC square is equals to AB square is 4 square plus 3 square. So AC is equals to root of 25. So that gives AC is equals to 5 centimeter. That means 5 units. 5 centimeters. So first we need to find AC length by using Pythagoras theorem. So after that, this is like angle of measurement. Angle of measurement. This is opposite. This one is like adjacent, we can say. And this is like hypotenuse. AC is the hypotenuse. Just remember. So then sine C is equals to, sine C is opposite. That is 4 upon 5 centimeter. That means 4 centimeter by 5 centimeter. Then cos C is equals to adjacent 3 by 5. Tan C is equals to, tan C is equals to opposite, that is 4 upon adjacent 3. Then cot C is equals to reciprocal of this tan only. So 3 by 4. Then cosecant C is equals to, cosecant C is equals to reciprocal of sine, that is 5 by 4. Next, secant C is equals to reciprocal of cos, that is 5 by 3. So like this we can find. This is one type of question. And another type of question is what here. Second example, some trigonometric ratio will be given to you. Suppose I am taking, if sine theta is equals to 7 upon 12. Find or verify. You will get question anyhow, like either finding the one expression value or verifying, like that you will get. So cos theta upon 1 plus tan theta value. Find this value. So to find this, we need cos theta and tan theta trigonometric ratios. So for that, what we do, just in any one triangle, takes like theta is the angle of measurement. In right angle triangle, suppose I am taking, this is angle of measurement. And then we know sine theta is equals to 7 by 12. 7 units by 12 units. That means sine mean opposite upon hypotenuse is equals to 7 upon 12. So opposite value is like for this 7x we can say. Don't take like only 7. And this one is 12x. By taking 7 and 12 also you will get it. But the thing is here, it is ratio. It may be in smallest. Okay. So then by using Pythagoras theorem here, we need to find this BC length. ABC if I assume. So BC length we need to find it. So that gives, in triangle ABC, AC square is equals to AB square plus BC square. So AC square is 12x whole square. 12x whole square is equals to 7x whole square plus BC square. That gives 144x square minus 49x square is equals to BC square. So 144 minus 49, that is 95x square is equals to BC square. So BC is equals to root of 95x. So BC value is root 95x. This is the value. So then here, what value we need to find? Cos theta upon 1 plus tan theta. So cos theta is adjacent upon hypotenuse, whole divided by 1 plus tan theta value is 7 by root 95. By using trigonometric ratios, we can simplify. So that gives root of 95 upon 12 into root of 95 upon 7 plus root 95. 7 plus root 95. Okay. So that gives 95 upon 12 into 1 upon root 95 plus 7. This is the value. Further you want to simplify, you can rationalize the denominator also. Okay. So hope you understood all these concepts. So introduction part, what is angle, positive, negative angles, measurement of an angle, trigonometric ratios, and few problems, like whichever types of problems you get in this. So I discussed all the types of problems also. Hope you understood. Thank you all.